So students, it's been clear. So we have a two label for each and every project which you are going to plan for it. One is the start and second one is going to be a finish, and then followed by we need to specify which are the activities being part of that particular project which you are trying to undertake. And each activity with the labeling conventions, we need to project out the information. So starting with the A and duration and the description. So in that way, we can go for framing this particular networking framework structure, and based on that constraint which has been given in your activity planning, which has been already given in a table format. Right. Now, once you complete this, the next one is we need to go for applying the forward pass mechanism. So here the forward pass basically to carried out to calculate the earliest dates on which each activity may be started and completed. So which is the earliest start date and earliest finish date. So that we need to identify. So for that, the forward pass is being used. So here, where an actual start date is known, the calculation may be carried out using the actual dates. So based on the actual date which has been given. So 3 weeks means the 3 weeks durations, we need to start from 0 and we have to specify 3. So that is the duration where you need to try to complete it. So alternately, we can use a day or a week numbers. So it depends on that the type of activity, and either maybe it will be given in terms of weeks or it may be in terms of numbers, in terms of days. So based on that, we need to specify on it. So by convention, the dates indicate that the end of the period of uh, end of the period, and the project is therefore shown as starting at the end of the week 0. So normally what will happen here at the beginning will be starting with 0. So that is the indication that we are planned to start on it. So nothing has been started. So that's the reason why they are using the 0, and the duration is going to be like we have already mentioned. So for example, for A, the duration is 6 weeks. So that need to be specified over here as a 6. So that's what they are trying to mean. Activities A, B, and F may start immediately, so that the earliest date for their start is going to be 0. And the activity A will take 6 weeks, so the earliest it can finish is 6. And similar way for B, 4. And for F, it is going to be 10. So which is the earliest finish. So earliest start is going to be 0, and the finish is going to be the duration. Whatever the duration has been specified, which is given in the table. Okay. So now this is the way we need to go for constructing it. So 0, 6 and 0, 4 and 0, 10. Next, we need to go for drafting the C. So at the earliest, when we can start C. Here, there is a constraint. They are stating that after finishing A only, we can start with the C. So that is the case. What is the earliest finishing date for this particular A? It's going to be 6. So for that reason only, we are starting on 6. And from there, we need to calculate the earliest to finish. So how will you calculate the earliest to finish? So where we need to have the earliest start date plus the duration. So 6 plus 3, 9. So 9. So the 9th week, we're able to complete on it. And similar way for the next one. So for the next one, again, after completing B only, we can start with the D. So that is going to be a fourth week is going to be the earliest start date, and finishing is going to be 4 plus 4, 8. And similar way for E also, constraint stating that after finishing only we can start with the E. So that is the case. 4 is going to be a starting week, and 4 plus 3 it is going to be 7. So the next one, we have a H. When you want to start H, where there is a constraint, they are stating that after finishing C and D only we can start. So here there is one more thing which we need to keenly note on it. So here we need to take that higher weeks. It's not that lower one, the higher value we need to take. So which is the higher value? So out of C and D, higher value, if you've seen that C is going to be the higher value. So that we need to consider as a starting of this particular H activity. So that means the earliest start is going to be 9th week. And from there, 2 weeks is the duration. So 9 plus 2, 11. So 11th week, we can able to finish off it. So similar way, the next one, which is going to be G. So for G, there is again a constraint. So after finishing E and F only, we can able to start with the G. So again, also again here also, if you check on it, so where we need to take the highest value. So here the highest value, like 7 is going to be the lowest and 10 is going to be the highest. So 10 will be taken into consideration. So that will be the earliest start of this particular G, and 10 plus 3, it is going to be 13 weeks. So this is the way the forward pass mechanism will work. Uh, so after this, which has been covered yesterday, and is it clear, students? In this, any doubt? In this, any doubt we can ask? Any doubt, students? Gibson?
So it is the calculation of how earliest an activity can start.
Yes.
And it can be ended.
Yes. So earliest start and earliest finish. That is what the thing we need to calculate on it. So
Okay,
while calculating, we need to check the constraints.
Actually, usually we have an activity in our project planning, sir. So
Yeah.
from that, this is like, is it a subdivision? It's like it is a method of identifying the earliest start and complete. Or?
Yes. This is the mechanism
Okay,
for
the same.
identifying. Yes. This is the mechanism for identifying which is the earliest date we can start this particular activity and which is the earliest to finish. We can do what?
With all the constraints.
Yes. So
sir,
you have.
So one more doubt, sir.
Yes, sir.
How is this thing related to the Scrum team, sir? Like we are studying in agile development, like there will be a Scrum team who will be working among all this.
Yeah.
So how is it related, sir?
That's what. How it is related means at the beginning of the when they are making a project schedule, so they have to put a project schedule. So when they are making a project schedule, they'll be specifying each and every activity, and along with that they'll be specifying the duration, and for that they'll be allocating the resources also, who is going to work on the particular activity, and again they'll be specifying the constraint also. So there are some constraints, something like you can take this example in hardware selection is going to be a first activity, and software design is going to be second activity. And when you want to start with the installing of a hardware, where hardware, if you select only, you can go for installing it. So that is what the constraint. So similar way for each and every activity, if you want to start on it, there will be a constraint. So the constraint also they'll be identifying, and they will be uh, uh, give on it. So once it has been given, it's not only about the activity constraint. Sometimes even the resource constraint also will be there. Here they are mainly targeting on activity constraint. But there are projects where resource constraints. So some of the resources, it's a very important resource, but that resource might be busy with the other work. So what they will do, they will meanwhile they'll be doing the other work, and once the resource being free, and this work will be allotted to the particular concerned resource. So these are all the constraints they'll be putting at the scheduling itself. So once they met the schedule, and that we need to convert into as a network diagram, because it's all multiple people have been involved and multiple resources have been utilized. So where we need to check that whether it will go in a proper flow. And for that reason only, this particular method they are adapting it, so critical path method, and through that they are trying to identify which are the critical events and which are the critical path also. So how will they identify? For that, they need to adapt one of the mechanism called forward pass and another mechanism called backward pass. So through that, they will identify which are the events which we can start, which date, and which we can able to finish on which date. So for that reason only, first we are adapting this forward pass, and through that we can able to identify. And when you go for a backward pass, where we can able to identify the slack value, and through the slack value, where we can have some kind of cushion, and through that we can, in case for some reason, if one of the event has been delayed, and we can able to make up if we have any slack values. If it doesn't have slack values, then that is going to be a critical event, and that need to be finished start on time, and you need to finish on time. In case if there is any delay, which is going to be critical for the project. So for that reason only, this particular diagram has been used. Hope I answered.
So like for example, like in a Scrum team, there'll be like a 3-layer, no, sir. Like a team leader, then we have the team managers, then we have the development team and all that. So like for this also, we have like for software development management also, we have like a team leader, and then we have the other members. So just like here also, we follow the agile model only, right?
Yes.
So
see, this is this one is like this is something like at the beginning. before taking up any model, whether you're going for agile or you're going for traditional waterfall model or you're going for bottom up approach or a spiral model, anything that you can do. But once you made that particular schedule, so once you made the schedule ready, and based on the schedule you need to work on it. So when you want to start working on it, you should know that how many resources are there and what is the duration, if there is any constraints. All these things you have to aware of it, right? So how will you aware? For that is only this particular CPM is going to give a clear picture about it. So these are the activities are being assigned for this particular project, and these are the resources are going to be worked, and how much duration they are going to work, and what are the constraints, and if there is any critical event which is being part of this particular project, entire things will be clearly, it will be visible to the entire team. So that is what this particular critical CPM does. And based on that only they can go for choosing any model for implementing it. Either maybe a Scrum, or it may be a Agile, or it may be a top down approach, or a traditional methodology, a spiral model. Anything they can use on it. But for that, this is the base. With that only they will start.
Okay, sir. Got it, sir.
Got it? Yeah. Right. So
Yes, sir.
yeah, forward pass completed. Next, we are going for a backward pass. So backward pass, there itself we have answer. It's coming from the end, and it will be reaching towards the front. So the reason behind it, why we are using a backward pass, to calculate the critical event as well as the critical path. So for that, this backward pass has been mechanism has been adapted. So the second stage in the analysis of a critical path network is being carried out a backward pass to mainly to calculate which is the latest date at which each activity may be started and it can be finished without delaying the end date of the project. Without delaying the end date, whatever the final target date. So without delaying that, how we can able to start at the late, because early starts it's must we'll be starting it. So in case of any delay is happening, which is the latest start we can do on it. So instead of first week, is there is a possibility we can start on second week, or is there is a possibility on third week. So that we need to calculate. So for that, the backward pass has been used. So we assume that the latest finished date for the project is same as the earliest finished date. So we need to have assumption stating that which is the latest start date, which is nothing that which is the earliest start date, and similarly, which is the latest finish date, which is going to be earliest finish date. So that is the assumption. With that, we need to start this particular backward pass diagram. Here again, if you see in this particular forward pass, already we have done it for this particular project selection. Here we need to identify which is the uh, here it is called earliest start date, and it's going to be earliest finished. And similar way, which is going to be earliest finish date of this particular project, if you see that which is going to be 13. So 13th one, which is the completion. 13th week we need to complete on it. So that is what the indication which is being given over here. So that means that is the one we have to take. So 13 is going to be taken over here. So that is the completion of your entire project. Entire project that need to be get completed within the duration of 13 weeks. So that has been taken as into consideration for the last activity, which is H and G. So we will go with the G first. So 13 is the latest finish date, and we need to identify latest start date, where 13, that is the earliest finish date minus the duration. So 13 minus 3 will be getting 10. Students, are you getting it? Any doubt on this? Because this is the first point. From here, it will we'll be taking towards the backward. So if you clear with this only, the remaining steps will be clear for you. If you have any doubt, you can ask me. So we have to identify which is the earliest finish date. So which is going to be 13th and 13th week, and that will be taken. And next we need to start the latest start date. So for that we can go for using 13 minus the duration. So that is going to be 10. And next again, here we need to take into consideration because the G is E is depending on G. So that's the reason why. So 10 we are taking into consideration here. So 10, then minus 3, it is going to be 7. And again, for this also 10 and minus 10, it is going to be 0. So this is the way the backward pass will work. And similar way for the next one, we have a H. So H is going to be the earliest finishing date is going to be 11, but the complete duration they are given 13 weeks. So that means we have 2 more weeks extra cushion is here. So 13 is going to be the latest finish date. Latest finish date, we can finish it by 13th week, because here, since this is there, that we are trying to utilize here for this activity also. So that is what the slack value will be getting it. So 13 minus 2. So that is the duration. So where we'll be getting the latest start date. So earliest start date, we need to start on 9th week, but latest start date, we can start even by 11th week also. Because of this, this additional 2 weeks that will be giving us a cushion for us. Okay. And next, for this, there are 2 dependent activities for H, D, and C. So again, when you're going for taking into considerations, so where we need to take that latest start date, which is going to be 11. So the 11, which we can use it over here as a latest finish date for the previous 2 activities. So 11 and 11 will be coming here. And now D again, 11 minus 4, which is going to be 7. And here 11 minus 3, it is going to be 8. So now these 2 activities are completed. And similar way for this also, already we have seen it. Next, we will go for a A. So in this A again, we need to take that latest start date is going to be 8. That we'll be using it here as a latest finish date. And here 8 minus 6 is going to be 2. So that means here we can later start by 2nd week. Instead of starting on the beginning, we can start by 2nd week also, which is there is a provision which is being given. Okay. And similar way, the next one, which is going to be 7. So 7 will be coming over here. So 7 minus 4, it is going to be 3. So that's all. So now all these values we got it. Now we need to identify the slack values. So slack value basically something like if there is any cushion value which we are getting it. So that's what we need to basically check on this. So for how will you check that particular slack value which you have it. So here if you seen that 13, so latest finish date minus the earliest finish. So where 13 minus 13, which is going to be 0, and 10 minus 10 also is going to be, so where it is clearly indicating that there is no slack value, which is going to be 0. And similar way, F also, if you've seen that, so 10 minus 10 is going to be 0. So here it's been clearly indicating that the critical event, which is going to be G and F, because it doesn't have any slack value, the slack value is going to be 0. If the slack value is 0, it is clearly indicating that you need to start on the first week and you need to complete within 10 weeks. And similar way, you have to start the user training by 10th week and you need to complete by 13th week. If there is a delay, then it is going to affect the event wise level as well as the entire project level also. So that is what they are trying to mean here. And similar way, if you calculate here, so 13 minus 11, it is going to be 2. So 2 is the slack value. And here if you seen that 11 minus 8, it is going to be 3. And similar way here, 7 minus 4, it is going to be 3. And here also 11 minus 9, it is going to be 2. And 8 minus 6, that is going to be 2. So here if you seen that we have a slack value, so 2 is here and 2 is here and 2 also is here. And here we have only here also 2 and 2. So where that critical event has been taken place, F and G only is the critical event. For any reasons, we should not be delayed. And for these events, we have a slack value, which is 2. So that means we can able to delay up to 2 weeks so that we can able to manage and we can able to reach the target. So, but for F and G, for any reasons, we should not be delayed. We should go according to the plan. If there is any delay, which is going to affect the overall project. So in that way, they will identify which are the critical events and which are the critical path. So hope you understand this. Students, any doubt on this?
No, sir.
So this is the way they'll be calculating the CPM, critical path method. where they're identifying the critical events and the critical path also. So here, if you see the critical path, F and G is going to be a critical path, and the remaining all, it's a normal path because we have a certain float value which has been there. So with that, we can able to manage and we can run the show. Even though if there is a delay which is there, we can able to manage it. So only thing is we can delay up to only the value which has been given over there. So the mean if it is 2 means 2 weeks we can delay. So not more than that. And similarly here they are given 3 weeks means we can able to delay up to 3 weeks. And if you go beyond that, which is going to create an issue. So till then you can do on it. But for F and G, there is no way you cannot delay on it. If there is a delay, which is going to affect the entire project. So this will be calculated at the beginning of the year, and they'll be identifying, and based on that, they'll be start doing the project. So through that, they can complete their project in a very effective manner. So that is what this CPM does. So hope you understand the importance of this particular CPM.
Sir, I remember you saying like there will be one value which will be calculated after doing the forward pass and backward pass, and one activity will be performed at that. What is that, sir? Like I don't remember that.
Which one?
Like they'll do the forward pass,
Hmm.
and after that they'll do the backward pass, and there will be, I guess, some average value, like some like value will be taken from the forward pass and backward pass, and they'll perform some operation on that. What was that, sir?
No,
I
they will
remember
be,
you saying that.
yes, yes. So they'll be identifying basically the float value. The float value,
What
right?
is it, sir?
Float.
Exactly. Yeah, that float
Okay,
value.
float. Yeah. So the float value, which is going to provide you uh, when they can start and when they can finish up it. If there is a possibility of delay, if any criticals are happening, so if there is a possibility, we can able to delay the particular event. So due to some constraints, maybe a resource constraints or maybe some other constraint, if it is happening in the project. So for some reason, if they want to delay it, if there is a possibility. So with that float value, they can able to identify, and through that they can do on it. If the float value is going to be 0, then it's clearly indicating that you cannot delay for any reasons. You need to start and you need to finish on time. So that is the one which is going to provide them a clear picture about that particular activity as well as the path also. So path, why they're saying path? Because it's all dependency task. Because G is depending on F. If F is being delayed, then automatically G also is going to be delayed. So that's the reason why the path also going to be a critical path. But here if you see that there is no critical path, because the reason behind it, we have a value 2, and here also 2, and here also 2 is there. So which clearly indicating that we have a provisions for some delay, but we cannot go beyond that particular delay also. That is also another important aspects. So these are all will be get considered when you go for doing your project. So that will be done at the beginning of the project scheduling itself. Once they're making a project schedule, and they will create this particular CPM, and through that they'll identify. So what are the resource constraints and what are the float value constraint which has been there, and based on that will be start working on that. Is it clear, students? And I'll be giving a set of problems to you people, and you can try to solve, so that it will be more clear for you. So if it is going to be an offline, I'll be explaining through board, and I'll be giving it. So since it's an online, so I'm just giving it in terms of virtually. I'm trying to give the all the informations to make it clear for you. And during the next sessions, what we'll do, we will go for. I'll be providing you one problem, and each one, like, you can just need to switch on your video, and you can just solve the problem and show me. Okay. So you, meanwhile, you can just go through this particular problem and study and come, so that you'll be having kind of an idea, and based on that we'll go for solve this particular problem during the next session, so which will be much more clear for you people. And based on that, I'll give you an assignment that is during the next, and that time you can go for attempting some more problem, and it will be much more clear for you people. Right. So Okay, so still now we have seen the diagram, and I've just explained about each and every activities and the constraints, and how to apply forward pass and how to apply backward pass also. So the next one is, even I told about this activity float also, how to calculate the float. And this particular slide, basically it is giving the formula, how it has been get calculated. So here, the time allowed for an activity to delay. So what is the time duration which we can able to delay this particular activity? So that's what it has been given in this particular slide. So there are three different types. First one is we need to go for calculating the total float. So for calculating the total float without affecting the completion of the project. So basically we need to identify which is the maximum duration which has been given. So the previous example, if you seen that 13 is the maximum duration. So without affecting that, so we need to take it. And for calculating it, latest start date minus earliest start date. So which is going to be a latest start date, and from there you minus the earliest start date, and with that you'll be able to get the total float. And second one is going to be a free float. So without affecting the next activity. So without affecting the next activity. So it's something like upcoming activity. So where earliest start date of the next activity. So which is going to be a earliest start date of the next activity minus the latest end date of the previous activity. So which is going to be a latest end date of the previous activity, and through that we can able to identify the free float. And the third one is going to be interfering float, where we need to have total float, which we calculated already, and minus the free float. And through that, we can able to get the time allowed for an activity to be delayed. So basically, which is nothing but an activity float. So through that, we can able to identify how much durations we can go for delaying each and every activity which is being part of the project. Now, what is the significance of this particular critical path in this particular project? So first one is during the planning stage. So whenever you're going for any of the project is being taken, so first thing is they need to go for planning. So when they are planning, so during that time, we can identify the critical event as well as we can able to identify the critical path also through this particular CPM. And once we identified where, we can able to find out whether there is a possibility for shortening the critical path, which will reduce the overall the project duration. So if there is any possibility, we can able to go for reducing the duration. Through that, we can able to do on it. So through that, we can able to avoid the risk. So that is what the first thing. And second one is during the management stage. So pay more attention to those activities which fall in a critical path. So here, since already we've been aware of that, which is going to be a critical event and which is going to be a critical path. So once you have been aware of that, we can give more attention towards the particular critical event as well as the critical path. And through that, we can able to complete the particular task on time. So that is the another significance when we are identifying the critical path in the project. So hope now you understand what is the importance of this particular CPM. And for each and every project, it's not only about software projects, even if you go for taking up any other projects. So the CPM is going to be one of the key mechanism, and through that we can able to identify which are going to be a critical path and which are going to be a critical event. And once you identify it, then we can give more attention towards the particular event as well as the path, and we can able to finish it on time. So that is the importance which is being given in this particular critical path method. And along with that, during the planning stage itself, be aware of that. Even we will be able to know that which are the activities going to be having some cushion values, and that also we will be keeping in mind. Accordingly, we can start working on it. And based on that, we can put some alternate plan also, where if there is any critical event is being coming, so we can find out whether it is possibility to add some more resources, and through that we can try to complete the task which earlier which is possible we can do on it. So these are all the important aspects when you go for using your CPM. And for this one of the key author for this particular SPM subject, which is nothing but Hughes and Cottrell. So these two authors, they have written the book on software project management. So that is going to be your syllabus book, and it is in a second edition, and the publisher is going to be McGraw Hill Publishers. So if you refer this particular book, which will cover the entire syllabus. Any doubt in this, students? If you have any doubt, you can ask me till then. So I'll give you the problem. So during the next class, where we can go for solving this particular problem, and through that you'll be having more clarity into that.
Sir, can I have a look on the activity float formula, sir? Once?
Activity float. Yes.
Ah, yes, sir.
Yes. This is the activity float formula. So number one is going to be total float. So where we need to have a latest start date minus the earliest start date. So that is the way we can calculate the total float. And free float, where we'll be calculating the earliest start date of the next activity, which is the upcoming activity, and minus latest end date of the previous activity. And through that, we can able to calculate the free float. And interfering float, which is basically something like total float minus free float, and through that we can able to calculate on this. For this, I'll give an example also. This I'm given just theoretical aspects. The formula I'm given. So the next time I'm going to give you the practically how it's been working on the same project which we discussed. So let me stop sharing it. I'll start sharing the other one so that it will be more clear for